Richard,
Pleased to meet you. Yes, come in.
Oh, wow.
Yeah, this is a little bit of a museum to the various prototypes we've gone through in the last 3-4 years. So.
Incredible.
It ended up being a little bit of an evolutionary journey, and actually started, dug this out, this horrible lump here. This was the very first prototype arm assembly.
That seems really heavy.
Yes, and it's got lots of sharp corners, and it was built in a hurry just to, yes, you can feel how heavy it is.
Oh my goodness.
Its weight reflects the uncertainty I had right at the beginning of just how sensible it was to have a jet engine attached to your arm. So I thought, well, let's just build it out of something really solid, so in case there's some kind of problem I haven't thought of, it's not going to hurt me. The conventional wisdom was that with a spindle spinning at 120,000 RPM, you would actually find that you couldn't move it. So like a spinning bicycle wheel, if you tried to move it, it would fight you in a perpendicular fashion. Turns out, not at all. It was easy, really benign. It was just a gentle but increasable shove of the air coming out the other end.
So that sounds like lesson number one.
Massively. And then rapidly went to the point, and they're stuck up on the wall up here. They are now heavily modified, and ignore the one with the plastic tube in it. I had a theory that if you put one either side of your fist, that the net result of the thrust would feel like it was going up your arm. So it now is just like you're leaning forward on a table. It's like very, very effortless. There's something we should point out as well. I've talked about the arm engines, but actually a large part of the support comes from the rear engine, which originally was an engine on the back of each leg. And we've got the original boots up in the corner there, which I used to use to house the engines, but they gradually moved up the legs until they were kind of on my posterior, and then eventually got consolidated into one larger engine here. And that provides a third of the lift to lift, a third of your body weight and the weight of the fuel and itself. So between those 3 points of the kind of camera tripod, that gives you the support to be able to actually manipulate and control and maneuver.
But you've gone through a lot of mistakes and failures.
You can see from some of the examples, we've had a few spills over the last 4 years.
My gosh, that's really mashed up.
Yeah, I mean, that learning journey was all about actually trying things that had never been done before, but all the time managing the downside, because actually, to be honest, it involved falling over, mostly on a farmyard where we were testing it. All the time, only from a couple of feet there. We always absolutely manage that downside risk. Otherwise, if you can't get back up again because you've broken your legs because you've gone too high, you can't keep innovating and trialing.
And this is your lab?
Yep, this is where we build, test, break things, rebuild things. Yep, absolutely.
I guess one of the key features that you're concerned about is how much it weighs.
Yeah, so anything that flies there has to be a consideration of the weight that you're trying to lift. Especially in our case, we don't have wings with this version. We are only flying by literally throwing enough mass of air downwards fast enough to lift you off the ground. Actually, an important point, a lot of people think this is pushing on the ground. The Newtonian physics doesn't work like that. This is simply blowing air downwards and you rising up. It doesn't make any difference whether you're 2 foot off the ground or 20 feet or 100 feet.
So it's a bit like pointing a hairdryer at the floor.
Yeah, even a domestic garden hose, when you turn it on, you can feel it shove you very slightly. It's that same force. There's mass being thrown that way, so naturally it wants to impart the same force the other way.
To understand this, we need to remember 2 things. 1, gravity is the weakest force in the universe. The reason we stay attached to the Earth is simply because it's so big. 2, Isaac Newton's third law of motion states that for every action, there's an equal and opposite reaction. So the action or the force exerted by the engines on Richard's body is enough to overcome the action or force of gravity, holding his body to the ground.
Actually, this is a 3D printed model of one of the engines. This is the one, the rear one in the back, the bigger one. Fundamentally, it's not dissimilar to the engine you'd have on a jet fighter or a civil airliner. You have an intake and a compressor, which compresses the air going into the engine. This is slightly different from a conventional large gas turbine in that the compressor is centrifugal. So it spins the air around the outside and then feeds it into the combustion chamber. The kind of engine you'd have on a 747 actually is a normal linear compressor, which takes the air straight down in one go. There's a bunch of kind of boring reasons why you have to go for a centrifugal one to get it small, but otherwise that's the main difference.
Linear compressors need to stack multiple pairs of rotating and stationary blades in what are known as stages. A single stage generally doesn't provide enough compression for applications like aircraft engines, so they're stacked in order to achieve higher pressures. Centrifugal compressors are harder to stack in multiple stages, but there's often enough total pressure generated by a single stage to be effective for smaller engines. They're also easier to design and ideal for 3D printing. So the manufacturing and size advantage outweighs the lower total pressure disadvantage.
So once the air's in the combustion chamber at high pressure, the fuel is injected in there. It's jet fuel or diesel or kerosene or paraffin, and that then burns, creates an expanded amount of hot air, which then escapes through the back. But the fun thing is, and you can see the blades in there, I mean, they're all printed, but you can see the little blades. They then catch in that airflow, and the rotation of that turbine wheel is what drives the compressor. And that's really it. So something that big will weigh about 5 kilos and put out about 55 kilos of thrust.
Enough theory, time for some action.
Just been given these because apparently it's going to get really loud, and now Richard is going to get his jet suit on. It's really exciting. How are you feeling at this stage? Have you done it so many times that it's kind of like second nature?
I have no concerns about my ability to fly. I always have a healthy respect for the fallibility of the technology, so that's why you don't go too high. So it's always a respect for that.
How are you feeling?
Yeah, it's great. Yeah, no, really good. I mean, it's a very simple little flight, but yeah, you see the control and stability.
Yeah, I mean,
Yeah.
you were just so stable, but you honestly looked like you were just floating on
Yeah,
air.
that's what it feels like. You just feel like you can go anywhere you like in three-dimensional space.
As well as being able to defy gravity, Richard is also the holder of 2 Guinness World Records.
Part of the reason we reset our own Guinness World Record back in November, I think it was, we improved it from 32 miles an hour to 85 miles an hour, and that was because we were using this leg wing with a series of little strakes and aerodynamic improvements on the legs, which helped lift my body flatter, which meant that particularly the rear engine was actually pushing pretty much entirely horizontally, which is why I just felt this great acceleration and started to fly more like a plane than a kind of hovering jet suit.
What kind of technology has come out of all of this work that will affect the way we fly?
Yeah, I mean, it's not unhelpful that and it's sort of accidental that a lot of people seeing us fly, their immediate go-to reference is a sort of Marvel superhero. I mean, that's kind of flattering and really quite fun. There isn't much like this that humans have done before. In terms of practicality now, this would not be my chosen way to take the kids to school or pop down to the shop for a pint of milk. But then again, the first motor cars were considered noisy, smelly, inefficient and terrible compared to the best technology at the time, which was a horse, perfectly good horse. And look where cars have got to. We've made amazing progress in the last 150 years of getting in flight vehicles and flying around inside them. Well, this is just opening people's minds to, if we go back to basics, what do we have to add to our human form in order to actually fly a bit like we always imagined?